What if the sun, our beautiful, life-giving star, suddenly exploded? It's a terrifying thought, right? But what would actually happen? Let's dive into this cosmic catastrophe step by step. First off, let's get something straight. Our sun isn't the type of star that goes out with a massive kaboom like a supernova. It's a yellow dwarf, and it's just not massive enough. Stars that go supernova are at least 8 times bigger than our sun. Instead, in about 5 billion years, our sun will swell up into a red giant, then gently puff away its outer layers and shrink into a white dwarf. It's more of a slow fade than a dramatic explosion. But for the sake of our cosmic thought experiment, let's pretend it could. Let's say, right now, the sun just explodes. What's the very first thing we'd notice here on Earth? Absolutely nothing. For about 8.5 minutes. Anyway, that's how long it takes for light, and any other form of radiation, to travel from the sun to us. So for 8.5 precious minutes, we'd be completely oblivious, going about our day, soaking up the last rays of sunshine we'd ever see. Then, it happens. The sky would erupt, not just with light, but with an unimaginable blast of energy, X-rays, gamma rays, and a storm of high-energy particles would hit our atmosphere first. Our planet's magnetic field and atmosphere are amazing protectors, but they wouldn't stand a chance against this. They'd be stripped away in an instant. The side of the Earth facing the sun would be flash-fried, sterilized by radiation so intense it would vaporize rock and boil oceans. Everything and everyone on the day side would be gone in a flash of blinding light. What about the night side? Well, they'd have a few more seconds, maybe minutes, of borrowed time, but they'd see it coming. The sky would light up brighter than 1,000,000 suns as our atmosphere on the other side of the world is literally burned away. The intense heat would wrap around the globe, and the shockwave of the explosion, a colossal wall of superheated plasma, and debris traveling at a significant fraction of the speed of light, would follow shortly after. This shockwave would be the ultimate planet killer. When it hits, it wouldn't just be like a strong wind. It would be a physical impact of unimaginable force. The Earth would be pummeled, torn apart, and possibly even vaporized entirely. There'd be no after, no survivors huddled in bunkers. The Earth itself would cease to exist as we know it, becoming just another cloud of superheated dust and gas expanding into the void. Let's zoom out a bit. What about the rest of the solar system? The inner planets Mercury and Venus, being closer to the sun, would have been obliterated even faster than Earth. Mars, the red planet, would suffer a similar fate. The shockwave and radiation would slam into it, stripping its thin atmosphere and scorching its surface into oblivion. Now for the gas giants, Jupiter, Saturn, Uranus, and Neptune. They're much farther away, so they'd have a bit more warning time. Jupiter, the closest of the giants, would see the explosion roughly 43 minutes after it happened. These massive planets might fare slightly better than the rocky inner worlds. Their immense gravity and thick atmospheres could offer some protection. They might not be completely vaporized like Earth, but they wouldn't escape unharmed. The sun's explosive death would blast their atmospheres, sending shockwaves deep into their gaseous layers and creating storms that would make the Great Red Spot look like a tiny puddle. They'd be violently pushed out of their orbits, sent careening into the darkness of interstellar space as rogue planets, no longer bound to any star. Any of their moons, like Europa or Enceladus, which might harbor life in subsurface oceans, would be sterilized by the radiation and then cast adrift alongside their parent planets. The Kuiper Belt and the Oort cloud, the icy frontiers of our solar system, would also be devastated. Comets and dwarf planets like Pluto would be hit by the blast wave and sent tumbling through the galaxy. Our entire solar system, a beautifully ordered and intricate cosmic dance, would be reduced to a chaotic, expanding cloud of debris and rogue worlds in a matter of hours and days. From a distance, say from our nearest stellar neighbor, Proxima Centauri, 4 light years away, what would observers see? They wouldn't see the explosion for 4 years. Then, one day, the star they knew as our sun would suddenly flare up, becoming one of the brightest objects in their sky for a few weeks or months. It would be a spectacular, yet somber, cosmic light show. Then, it would fade away, leaving a dark patch in the sky where a solar system once thrived. Astronomers of a distant alien civilization might record it as a transient astronomical event, a brief cosmic firefly, completely unaware of the life and history that was just extinguished. So, could we survive? The short answer is a definitive no. Not on Earth, and not anywhere else in our solar system. The sheer scale of the energy released is something we can't even truly comprehend, let alone build a defense against. We couldn't outrun it. Our fastest spacecraft would be like a snail, trying to outrun a tsunami. We couldn't hide from it. No bunker, no matter how deep, could withstand the planet itself being torn asunder. It's a bleak scenario, isn't it? But here's the good news. It's pure science fiction. As we said at the beginning, our sun is a stable, middle-aged star. It's not going to explode. It has billions of years of fuel left in its tank, and its end will be a slow, predictable process. It gives us a profound appreciation for the stability we enjoy. The sun isn't a ticking time bomb. It is a reliable furnace that has allowed life to flourish on this little blue for billions of years. These cosmic thought experiments are fascinating, but they also serve as a powerful reminder of how precious and fragile our existence is. We live in a perfect cosmic neighborhood, at just the right distance from a well-behaved star. It's a gift of cosmic proportions. So the next time you feel the warmth of the sun on your skin, take a moment to appreciate it. It's the source of all life on our planet, and thankfully, it's not going anywhere anytime soon. Thanks for joining me on this explosive journey through the cosmos. If you enjoyed this and want to explore more what-if scenarios, make sure to hit that like button and subscribe for more adventures into the unknown. See you next time.